In this video, we have a couple of questions that rely on similarity to answer the questions. So in the first question, we have triangle ABC, and it's similar to triangle DEF. We want to use that fact to determine if sine of D or sine of E is going to be equal to cosine of A. Now, if we know that these two triangles are similar, it means that all the corresponding angles are going to be equal. So the first angle here is A, matches up with angle D. So we know that this angle A is going to be congruent to this angle D. And then C and F are both the right triangles, or I'm sorry, right angles, so those are going to be congruent. And then we also know that B is going to be matched up with E. So then B is going to be congruent to E. Now if we're going to find the value of cosine of A, we're going to use this angle right here, A, and cosine is the adjacent side, which is this side right here, and it's going to be divided by the hypotenuse. Remember, we always refer to SOHCAHTOA. So the C is representing cosine, and then you've got adjacent divided by hypotenuse. So let's start by checking off if sine of D matches up. Okay, so our angle D is up here, and we're looking for sine. So that's going to be the opposite over hypotenuse. So the opposite side of angle D is the side that you can draw a line to, and it's going to hit it. So this is going to be the opposite side. And then the hypotenuse is always the side that's across from the 90-degree angle, or it's going to be the longest side of the triangle. So this is going to be the hypotenuse. Now another fact about similar triangles is that the corresponding sides all have the same ratio. So for cosine of A, you've got AC right here, the adjacent side, and that's going to be matching up with DF right here. But for sine of D, what we just figured out, we don't use this side at all. So it looks like sine of D is not going to be equivalent to cosine of A right here. So let's go ahead and try sine of E. Here's angle E. So sine, again, is going to be opposite over hypotenuse. So the opposite side of angle E is going to go across here, and that's going to be labeled as opposite. And then once again, we have this side being our hypotenuse. That never changes. Opposite and adjacent sides would change based on where the angle is, but hypotenuse always stays the same. It's going to be the longest side of the triangle. But now you could see that the opposite side right here, which is DF, that corresponds with AC right here, which is the adjacent side. And then we also have the hypotenuse over here that matches up with this one right here. So we could say that cosine of A, and I'll write this out down here, cosine of A is going to be equal to sine of E. And if you're thinking like, whoa, wait, how do you know that? We don't even have any values. Well, remember that the corresponding sides of similar triangles are going to be in proportion. So as long as we have AC divided by, it looks like AB here on this left side, that matches up with DF on the right side, or I should just say the right triangle over here, and that's going to be divided by DE. So let me erase all this so you can see it a little bit clearer. So to recap, cosine of A is the same thing as AC over AB because it was the adjacent side over the hypotenuse. And then sine of E over here is DF over DE because that was the opposite side divided by our hypotenuse. So once again, these ratios have to be the same because these triangles are similar. For the second question, we're going to use similarity to come up with our answers as well. The first one we want to figure out is cosine of L. So I'm going to bring up SOHCAHTOA again. And since we're using cosine, we're going to use cosine right there. That's going to be adjacent over hypotenuse. So the adjacent side divided by the hypotenuse side is what we want. And we're working with L, so we have to take this angle right here. Now, if we draw a line across from L, this side is going to be the opposite side. But do we want that? No. Alright, what else do we want? Well, L to H, that's going to be the hypotenuse because it's the longest side right here. Okay, that leaves 24 equaling the adjacent. Sometimes I like to label all my sides, and that helps me figure everything else out. Okay, so the adjacent side, we have that's 24. And we're going to divide by the hypotenuse, but we don't have the hypotenuse. How could we find our hypotenuse? Well, this is when you got to go back to the fact that these two triangles are similar. If we know that WCE is going to be similar to LMH, we know that the corresponding sides all have the same ratio. So as you can see, WC corresponds with LM. So how did we go from 8 to 24? Well, 8 times what number gives us 24? That's a 3. 8 times 3 gives us 24. So then you could take 17, multiply that by 3, and that's going to give us what, 51? So then that's what the hypotenuse is going to equal, because 17 times 3 is 51. And then down here, 15, we could multiply that by 3, and that's going to give us 45, which is what our hypotenuse will equal down here. I'm sorry, not our hypotenuse, our opposite side. Now we have all of our sides, and the one we have to plug in, it looks like, is our hypotenuse, which was 51. So we found some extra information, but what we needed right here is 24 over 51. Okay, now on the cosine of h. So we're going to use this angle, and once again, cosine is adjacent over hypotenuse. So same thing. Now, the opposite side of h, I find that by drawing an arrow at it. So I'm not going to use 24 because that's the opposite side when we're using angle h. We want the adjacent side. So the adjacent side is going to curve over here, and it's going to be 45. So that's going to be the adjacent side of angle h. I'm sorry. Yeah, angle h. And then the hypotenuse for h is going to be 51 as well. The hypotenuse never changes. It's always the longest side of our triangle. So these two fractions right here are going to be the answers for cosine of L and cosine of h. We knew that because our triangles were similar. If we didn't know that these triangles were similar, I'm not sure we'd be able to find those answers.